So far in Algebra 1, we have been dealing with equations or linear equations, and we've been graphing them and solving them and writing equations. What we're going to be doing now is putting two or more equations together and calling them systems, and we'll be learning how to solve different systems. And throughout this whole entire unit, we'll be looking at different ways to solve systems. In this specific video, we'll be learning about solving by graphing. So at the end of this lesson, you'll be able to find the solution to a system of equations by graphing. All right, first of all, before we even look at a solution of a system of linear equations, what does a system look like? A system is going to look something like this. I might have 2x plus y equals 6. Notice that's one linear equation. And then I might have 2x minus 5y equals 4. That would be another equation, and when I put those two together into one problem, it becomes a system. All right, so then what does it mean to find the solution of a system? It would mean to find the point at which the two lines intersect. So if I were to graph those, two lines, where would they cross? All right, another way of looking at it, if I don't want to graph it and do a different way, it's going to be that point that makes both equations true. So what point could I plug into both of those and get a true answer? All right, there are three different things that could happen to a system of a solution to a linear system. The first thing is I could draw one line, and it might look like that. And I'll draw another line, and it ends up looking like that. And notice they do intersect. So that's one thing that can happen with two linear equations. So they intersect, and if they intersect, they're going to intersect in one place. So there will be one solution. Right? Another thing that could happen, we studied this last unit, we could have lines that never touch because they're parallel. So our second case would be that the lines are just parallel, at which point there will be no solution because they're never going to cross. Right? And the third thing that could happen is I will draw, one equation will give me a line that looks like that, and then the second equation ends up being the first equation in disguise. It will end up going right on top of the other equation. And if that happens, that's called that the lines coincide. And notice they always touch, so that there are going to be an infinite number of solutions. So those are the three things that can happen as we're going through, and we'll actually solve them and find that that's the case. All right, like I said before, we're going to just focus today on solving a system graphically. The three steps are to, number one, graph equation 1, number 2, graph equation 2, and then our answer will be to write down the point of intersection. Right, so we've become good at graphing, and that's going to help us when we do this lesson. Whoop, intersection, sorry about that. Alrighty, so let's try. We've got y, it says to solve each system by graphing, so when we're done, we will say where they intersect. So the first line is going to be y equals 2/3 x plus 1, and the second line is going to be y equals negative x, I actually want that to be a plus sign, please, plus 6. So we're just going to go ahead and graph equation 1, and if you recall from graphing in Unit 2, the first thing we're going to circle the one that doesn't have the x on it, so we're going to start at 1, and then from there we're going to go up 2 over 3. Up 2 over 3. And then we can go ahead and connect. You will find on these, the more dots we make, definitely the more accurate my graph will be. And then the second one, again, we're going to start at the one without the x on it, so we'll start up at 6. And then from here, since the slope is negative, remember that really has a 1 over 1 in front of it, we'll go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then we'll go ahead and connect those as well. And then we're not done because we have to solve it by saying where do they cross. So I notice they cross right here, and that point would be, we'd have to go to the right 3 and then up 3, so that point is going to be 3, 3. This was going in the x direction, and this was going in the y direction. All right, let's try another one that's not solved for y. Let's say we have negative 2x plus y equals 6, and negative 4x plus 2y equals 12. Right? Depending on how you graph this one, I'm going to do this two separate ways, so you'll want to fast forward for the way that you don't want to see. The first way that I'm going to do it is the cover-up way, so if you're a cover-upper, stick with me, otherwise just fast forward to the solving for y way. Okay, if we cover up, if I have the x covered up, I have the y covered up, just pretend like it's not there. To solve for x, we divide both sides by negative 2, and we're going to get x equals negative 3. And then if I cover up the x, I just have y equals 6 left. So I know that y equals 6. And now if you recall, to graph that, we'll just go over to x equals negative 3 and put a point. We'll go up to y equals 6 and put a point, and then we will connect them. All right, and then for the second one, we would, same thing, if I have the y covered up, I have negative 4x equals 12. I'd divide both sides by negative 4, and I'd get x equals negative 3. And then I'd cover up the x, so I'd have 2y equals 12. I'd divide both sides by 2, and I get y equals 6. So once again, I go to x equals negative 3 and y equals 6, and notice I get the exact same line. So that second one was just the first line in disguise, and since they always touch, they coincide, we will say that there are infinite solutions. All right, I'm going to do the solving for y way now, so if you're done with this problem, just fast forward to problem number 3. Okay, solving for y, for you solving for y people. All right, solving for y, I'm just going to add 2x to both sides. So now I just have y equals 6 plus 2x, which if you recall, we're going to start up at the 6. We'll go up 2 over 1, and notice that ends up being the exact same line that's already there. And then for the second equation, we're going to add 4x to both sides. So those are gone, and then I'll divide every part by 2. And when I do that, I get y equals 6 plus 2x. Notice it's the exact same equation, which will make the graphs go on top of each other, which means there are infinite solutions. So now everyone should be ready to go on to problem 3. All right, number 3. Again, solve each system by graphing. Let me go ahead and put points in there for you. We've got y equals negative 2x minus 1. And then y equals 2x. I do not want this to be plus. I'd prefer it to be minus. And then let's do minus 5. And then I would love for you at this point in time to pause this video, and yes, I do expect you to pause it. Try it on your own, and then see if you get the same answer that I do. So I should see you pausing your video right now. Okay, so hopefully you're back now and you're coming to check. I'm going to start at the 1 without the x on it, so I'm going to start at the negative 1. I'm going to start down at negative 1, and then the slope is negative 2. So I'm going to go down 2 over 1, down 2 over 1, and then I'm going to go ahead and connect it. Oh goodness, I hope your line was straighter than mine. Alright, and then the second one we're going to start down at negative 5, and then from here, since my slope is 2, I'll go up 2 over 1, up 2 over 1, and then I'll go ahead and connect them, and then it's easy to see that they cross right here, which is to the right 1 and down 3. So you should have an intersection point of 1, negative 3. All right, let's try the last problem. 2x plus y equals 5 and 2x plus y equals 3. Again, there's two different ways to work this. I'm going to do the cover-up way first. So if you're solving for y person, you can just fast forward to that method, or you can try this on your own. Actually, it would be nice to try this on your own. How about you do that? All right, so if you're a cover-up person, if I have the y covered up, I'd have to divide both sides by 2, and I'm going to get x equals 2.5. And then if I cover up the 2x, I'll just have y equals 5. So I'll go to y equals 5, and then I'll go to x equals 2.5. 1, 2.5 right in the middle there. And then we're going to go ahead and connect them. Right, and then the second one, if I have the y covered up, I'll divide both sides by 2. 3 divided by 2 is 1.5, or 1.5. And then my y, if I cover my x up, y will just equal 3. So I'll go to y equals 3. And x equals 1.5 is going to go right there. And once again, we'll just be right there. And there we go. You'll notice that these lines are parallel, so they do not intersect, so there is no solution, or no solution. If you would like me to go ahead and solve for y way, if we have 2x plus y equals 5, we'll subtract 2x from both sides. And so I'll get y equals 5 minus 2x. We'll start up at 5, go down 2 over 1, and notice I get that same line. And then the second one, we'll again subtract 2x from both sides, so I'll just get y equals 3 minus 2x. So I'll start up at 3, I'll go down 2 over 1, same line again, they're parallel, there is no solution. So hopefully you know how to solve a system of equations by graphing.